In this video we are going to see what happens in a refrigeration or air-conditioned system when dimensions of the capillary tube are not correct. This can happen especially when we replace the compressor and we only pay attention to the power of the compressor motor, but we do not verify the cooling capacity. We are going to have 4 cases: larger, smaller than we should have, larger diameter than system needs, or smaller diameter. There are 4 cases. Let's see the first one. When we place a longer capillary tube than the system should have, then we will have greater of the basic refrigerant flow. That is, we are going to have a lot of restriction to the passage of the refrigerant through the longer the capillary tube, the greater control over the basic flow we are going to have. Therefore, if we are going to have greater control, greater restriction in the capillary, we are to have more refrigerant on the side of the capacitor. If we have more refrigerant on the side of the capacitor, then we are going to affect especially high pressure. Of course, low pressure can also be affected because everything is a system, but the length of the mostly affects the high pressure. Without rule out that there are variations in the low pressure, the main effect will be in the high. When we affect the high pressure, then we are also directly affecting the power consumption of the. Let's go to the second case, when we place a smaller capillary tube than the one we should have, a length. When we place a shorter length, then we are going to have less control, less of the gas flow. Therefore, the gas will come out more easily from the capacitor and will reach the evaporator. Therefore, the high pressure will decrease significantly. Of course, low pressure will be affected because more refrigerant will reach the evaporator and low will try to go up a little. But the greatest effect when we have errors in the length of the capillary will be related to the pressure. What is going to be most affected is the high pressure. We are going to have a lower high pressure. And the problem is that the high pressure drops to such values that the condensation in the is not carried out. Why? Because for condensation it is essential to have the appropriate pressure values. If we do not have a high enough pressure with the sufficient value, then we will not be able to the refrigerant at room temperature. Then we are going to have an alteration of the cycle. Let's go to the third case, which is related to the diameter of the capillary. What happens when we place a larger capillary diameter than we should have? Now we're going to leave the length fixed. In the previous case, we left the diameter still and variations were made only of the length. Now we are going to do the opposite. We are going to leave the length still and we are going to modify only the diameter. What happens when we place a larger diameter than the normal value? Diameters affect especially low pressure. It does not mean that high pressure does not affect. High pressure will also be affected. Of course, it will be affected. But mostly we are going to see the failure in low pressure. Without saying that high pressure is not affected. Of course, by placing exaggerated diameter values, it will reach certain values where the high is not achieved. Because there's no restriction. We are saying variations of slightly larger or slightly smaller diameters. So what happens when the diameter of the capillary is greater than normal? We are going to have a great effect on low pressure. We are going to lose low pressure and we are going to have a noticeable decrease in high pressure. When we affect high pressure, we affect the power. That is, the power is going to decrease. Now what happens in the fourth case when we place a smaller diameter than we need? When we place a smaller diameter than we need, the greatest effect will also be on low pressure. It does not mean, I repeat, that high pressure is not affected. Because it is a complete cycle. Everything is going to be affected. But what we are going to see the most is, in at low pressure, the effect. When we have a smaller diameter, we are going to have a noticeable decrease in low pressure. When we place a smaller diameter than required, we are going to have an increase in high pressure. The high pressure is going to increase. And then when the high pressure increases, we are going to immediately have an increase in consumption. So, in short, when we are making a change in the compressor, we have to verify the cooling, the BTU per hour, kilocalorie per hour or what, that the new compressor and the capillary that we are going to install will have. It has to have a corresponding diameter and length value. Not to the HP, but to the cooling capacity of the new compressor at the working temperature that we going to install. See you in another video.